Alrighty, question 2. The number of cancellations in a hotel in a large number of 1 week intervals, so we've got 1 week intervals but lots of them, is produced in the following graph. Now what do we have to calculate? It says, calculate the expected number of cancellations in any one given week. So 45% of the time there was no cancellation. I'm actually going to put cancellations 0, 1, 2, 3 and 0.45% of the time. There's one cancellation 30% of the time. There's two cancellations 15% of the time. And there's three cancellations 0.1, 10% of the time. Now, to get the expected number, we can go this times this, plus this times this, plus this times this, plus this times this. But I think you asked for the standard deviation as well. Are you not? Oh, maybe you're not. Okay. So you can be using this formula on the formula sheet, which is here. Expected number is the sum of all the x's times the probability of that happening. So that just means this times this, plus this times this, plus this times this, plus this times this. The other way that you could do it, which is a cool trick for lots of uses, is to go into stats and on list 1 have the 0, the 1, the 2, the 3, and then on list 2 have the 0.45, the 0.3, the 0.15 and the 0.1. Here comes the important thing. When you go calc, you have to go set, and in frequency has to be in list 2. And then we go 1 var, and we have got a mean equals 0.9. And we're going to have a standard deviation of that standard deviation looks wrong, doesn't it? N equals 1. Something's wrong here because n is not 1. So let's see what's happened. I've got all of that right. Then when I set, okay, execute, and 1 var. That is so weird. Okay. So standard deviation equal to 0.995. If we just think about that, the cancellations, if we had 0.9 there, plus or minus basically 1, that would be 1 standard deviation. It does actually make sense. So we've got our mean of 0.9. So let's look at our schedule for that question, question 2. We have got the mean of 0.9. Okay? So that's cool. Now, next one. We didn't need the standard deviation, but sometimes you are asked. The hotel manager wants to reduce the number of cancellations. He starts an initiative to make the hotel cancellation free. This is defined as no more than 1 cancellation in any 2 given period. So if lambda equals 0.9 for 1 week, then lambda equals 1.8 for 2 weeks. So I've already decided that it's Poisson. Okay? However, I've got to explain to you why. Using your answer in part A and an appropriate distribution to model the situation, calculate the probability of there being no more than 1 cancellation, probability no more than 1 cancellation. So the probability of x being greater than equal to 1, sorry, we need it to be less than or equal to 1. The probability of no more than 1. So you can have 0, you can have 1 in any given 2-week period. So we're looking at that. So when it says here, use your answer in part A, your answer in part A was the mean was equal to 0.9. You've got no other information. So as soon as you're asked to find an appropriate distribution and you've got a continuous time frame and you've got an average, then it's Poisson. Okay? So we've got the trick of lambda 0.9 for 1 week becomes lambda 0.8 for 2 weeks, and then we need to grab our calculator and go into stats, exit out of there, exit out of there, distribution, we are the Poisson, we're PCD because we've got the less than or equal to, and we're a variable, and x, we're less than or equal to 1, and lambda is 1.8. So we get 0.4623. And I'm just going to check on our schedule. Okay, so that's cool, but now the language. Apply this distribution because discrete events, cancellation within continuous time frame. So the discrete events are the fish, the continuous time frame, the water. We need to contextualize it to this question. So the discrete event is a... What's the discrete event? Cancellation. The discrete event is the cancellation, and the continuous thing is the time of 1 week. So discrete events, cancellations, that's putting it into context, that's getting you up to merit. With a continuous interval, time, this is again using the context, so getting you to merit. It cannot occur simultaneously. Each booking can only be cancelled once. That's like 2 fish can't take up the same space. Cancellations are random occurrences without a pattern. Okay? These are the conditions you need to learn off by heart. Cancellations is just like your discrete event, like your fish. We can't tell where it's going to be in the water. For a small interval, the mean number of occurrences or cancellations is proportional to the size of the interval. So that idea of proportion, and again contextualize it with cancellations. Assumption that any cancellation occurs independently. So those are your conditions that you've got to learn off by heart for the Poisson, and that will get you merit grade. Okay? So back to here. What is our next question? After changes in the cancellation policy come into effect, it is observed that the proportion of days without cancellations was 95%. So the x equals no cancellations, 0.95. Can the hotel manager now be satisfied that the hotel is cancellation free, no more than 1 cancellation in a 2-week period? So we're going to take lambda as 0.95 for 1 day. So lambda for, hang on. Sorry, that was a brain freeze. We're going to this to the formula sheet, and we are actually going to go to the Poisson. Okay. bell about to go. So we're looking at the Poisson distribution, this one here. The probability of x equal to 0 equals lambda to the power of 0 is 1, and so lambda to the power of 0, e to the negative lambda, and then underneath we've got x factorial. Lambda to the power of 0 is 1, 0 factorial is 1, so we get e to the negative lambda. So back to our schedule, back to our thingy. We know that e to the negative lambda equals 0.95, so lambda equals negative natural log 0.95. You need to just learn that off by heart, I think, at this stage of the year. So we go menu, we go through here, we go negative ln, which is there, and 0.95, and I get lambda equals, now just check that's right on my schedule. Yes, for one day. Bye. Hi.